Hi everybody and welcome to day whatever number this is. Today we're going to be talking about the area of triangles and trapezoids. So we are going to be talking about where the formulas come from along with actually doing some problems that involve triangles and trapezoids. So you may remember there are tons of kinds of triangles. We have right triangles, acute triangles, obtuse triangles, scalene, equilateral. No matter what kind of triangle we have, they all have the exact same formula. So all triangles have the same formula, no matter what direction they're turned or how big or how small or what kind of triangle it is. And that formula is 1/2 base times height. So I do want to talk about where that comes from, and to do that we're going to look at this question. What is the relationship between the area of a triangle and the area of a parallelogram? So yesterday, or whenever you looked at this video, we talked about parallelograms area, and we came up with the formula A equals BH. So this is the formula for our parallelogram. So how is a triangle related to a parallelogram? Well, we're going to start out with a parallelogram that you're really super familiar with, and that is a rectangle. So if we have a rectangle, we know it's a rectangle when we have 90-degree angles in the corners, right? So the area formula for a rectangle, because a rectangle is a parallelogram, is base times height. So you might have said length times width. I'm just going to say base times height for this. Base and height. It's really important to note that your base and your height will always be perpendicular, which is why this part here can be our base and that part there can be my height. Now, the base is not the bottom, so we get used to writing base as the bottom, but if I had turned my rectangle this way, this could be my base and this could be my height. So it doesn't actually matter which one is your base and your height as long as they're perpendicular. Now, this is not a rectangle, this is not a triangle clearly, but if we took this rectangle and cut it in half, this part is a triangle. In fact, it's a right triangle like this one is up here. So this right triangle is literally half of a parallelogram. So the area of our triangle then is half of our parallelogram. That means the area of our triangle is going to be half base times height. So you can see here that we can actually make this a rectangle. That's base and that's height. We only want half of it. Now that's pretty clear for right triangles because we can make those into squares, into rectangles very easily. But how does this formula or this formula right here relate to a parallelogram? Well, I am going to propose that it's still half of a parallelogram, just instead of it being half of a rectangle, it's actually half of a parallelogram. So if I were to draw the other triangle over here, do you see now that we have this entire thing right here as our parallelogram? So if this entire thing is our parallelogram, I can call this the base, and you can see that that's just the base of the triangle is also the base of the parallelogram. And then where would our height be? Well, our height can be anywhere as long as it's showing that it's perpendicular to the base. So I could put my height here, I could put my height here, but since we're ultimately trying to deal with this triangle, if I put my height right here, so it's perpendicular to the base, this is the base of the parallelogram. It's also the height, this is the height of our parallelogram. It just so happens it's also the base and the height of our triangle, which means this triangle is literally half of this parallelogram, and we know the area from our parallelogram is base times height, so the area of this triangle would be 1/2 base times height. All right, so what about this guy? Well, the same thing is going to happen that happened over here. I might just draw my triangle in a little different spot. I could draw my other obtuse triangle out here somewhere, but if I just draw it so it's here, do you see now we have a parallelogram? So base times height, right? Now if I put my height right here, this dashed line is not representing the height of my triangle, which is where it gets a little confusing. But don't forget, your height can be anywhere as long as it's from the very top to the very bottom and it's perpendicular. So what if I took this height and I moved it down here and put it outside of my shape? Well, if I put it outside of my shape, now not only is it the height of the parallelogram, but it's also the height of our triangle. So this is literally half of a parallelogram. So we're right back to 1/2 base times height. All right, so now that we know the formula, 1/2 base times height, there's actually a different way we can write it. Sometimes people don't care for the 1/2. There's actually a couple different ways you can write it. You can write 0.5 base times height if you prefer decimal, or you can do base times height divided by 2. So whichever of those make you happy, there is no one right formula as long as it's representing the same thing, base times height, and then we want half of that. So base times height divided by 2 or 1/2 base times height. All right, so let's put some of this into practice now. So let's look at example 1. Find the area of the quadrilateral given that AC is 35 inches. So let's take a minute and let's notice some things about this quadrilateral. So first, it is a quadrilateral, which means it has 4 sides. This quadrilateral is not a parallelogram because 1, it didn't tell us, and 2, these sides, like these maybe could be parallel, but these are not. They will eventually intersect, like if we were to keep drawing them. And remember, a parallelogram must have 2 pairs of parallel sides. So we will not be able to use the parallelogram formula. However, you might see that this quadrilateral is split into 2 triangles. So if I wanted to find the total area, couldn't we find the area of this top half and then this bottom half and just add them together? Let's try that. So the area of our quadrilateral is going to be the area of, I'm going to call it triangle 1. So I'm going to call this first triangle here in blue, just call it triangle blue. Triangle blue. And we're going to add to that, I don't have a different color. I only have blue pens apparently. So we'll call it triangle pencil. Triangle gray perhaps. Triangle gray. So we're just going to find the area of the 2 triangles and add them together. All right, so how do we find the area of the triangle? It's 1/2 base times height. So 1/2 base times height, 1/2 base times height. So let's start with the blue triangle. What is the base of the blue triangle? Well, the blue triangle's base is, in this case, AC, not because it's the bottom, but because this guy right here is perpendicular to it. So remember, base doesn't have to mean bottom, it just has to be perpendicular to what you're going to consider the height. And since I already know this is 10, and that's perpendicular to it, I'm going to call AC my base. Now it tells us in the problem that AC is 35, so 1/2 times 35, and then your height will always be perpendicular to your base, so since our 10 is perpendicular to AC, that's going to be our height. Now our second triangle, this one down here, the base and the height, remember, are perpendicular, so this dotted line and this dotted line are going to represent the base and the height, so AC is going to represent my base again. So my base is the same, they're actually sharing the same base, so 35. My height is different though, this time it's 17. All right, so now we're just going to do the math. Now the order you do the math is completely up to you. You can do half of 35 and then 35 times 10. You can type all of this into your calculator at once. So I'm going to use what's called the associative property, which allows me, the commutative property, which allows me to multiply in any order I want. So I don't have to do half of 35 first. I can actually do 35 times 10 first. I know that that's 350. And the reason I'm doing that is just because I don't have my calculator super handy. And 35 times 10 for me is pretty quick. So then half of 350, or 350 divided by 2, that's going to be 175. And then over here, I don't know 35 times 17 easily, so I'm just going to use my calculator for all this. Please make sure you're typing this in yourself too, and not just assuming I'm right, because some of you have noticed that I've made a couple mistakes on answer keys. It happens to me the same way it happens to you. Sometimes I mistype something on my calculator, or my finger slips, and I don't notice it. So I need you to help back me up. So I got 297. Oops, but I wrote 5. 297.5. So I'm going to add that to 175, making my total area 472.5 inches squared. So don't forget that the area is always square units. I don't know if Miss Freeze in the last video, she's the one that did the video on parallelograms, actually talked about why units are squared, but literally units are squared because way back in the day, people tried to find the area by literally breaking a shape into squares and then counting them up. So like here you can see I have 1, 2, 3, 4, 5, 6, 7 full squares, and then we would take all of those other little bits and kind of figure out how much extra there was left over. But literally what this means is if I were to cut this into 1 inch by 1 inch squares, 472 and a half of those squares would fit in there. So that's why your units are always squared. All right, so let's go a little bit different direction now. So in this first problem, we were finding the area. In this second problem, we're actually gonna find the height and we know the area. So we're gonna do a little bit of algebra manipulation here to solve this problem. So it says find the height of a triangle whose base is DE. So we know our base is DE is 28 and whose area, so our total area is 125 inches squared, which means if I were to draw in 1 inch by 1 inch squares, there would be 125 of them that fit in there after we like took all those pieces to make them full squares. All right, so we are going to try to find the height. Now, if DE is representing our base, then our height is going to represent something perpendicular to that base. So I could draw my height anywhere as long as it's perpendicular, but I'm actually going to draw it from this vertex over here, F, and I'm going to draw it straight down. Now, I do know that this is outside of my shape, but that's okay. Your height is just representing from the very tippy top to the very bottom. So where that falls is totally okay, inside or outside. I'm just going to kind of show that that's where my height is. So we're going to find this. I'm going to call it H. Now, if we know our formula is 1/2 base times height, instead of knowing all of this and plugging it in to find A, now we're going to know A and B, and we're going to do some math manipulation to find H. So our area, 1/2 base times height. And again, if you like base times height divided by 2, by all means use that. So 125, 1/2, my base is 28, looking for my height. Now, we can do the math in whatever order we want. I'm actually just going to do half of 28 first, because that is where my brain goes. But you could multiply both sides by 2 to get rid of the 1/2. You could divide both sides by 28 to get rid of the 28. I'm just going to do this math here, because half of 28, 28 is even. So for me, I can do that pretty quickly. So half of 28 is 14. And then here we're just at a regular old equation now. So I'm going to divide both sides by 14. I cannot do that in my head. I think that's going to be a decimal. It is. I got 8.92857, blah, 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 blah. I'm going to round that to one decimal place, 8.9. And then my units were inches. Only area will have square units. Heights, bases, lengths, widths, those will always be regular units along with perimeter, regular units. So when you type this into your calculator, please make sure you get 8.9. If you don't, try again. If you still think that I'm wrong, it's totally possible. Send me an email so I can fix my video. All right, now we're going to talk about the area of a trapezoid. So kind of how I kind of explained where the area formula for a triangle comes from, I want to explain where the area formula for a trapezoid comes from. Now, you may have seen the formula before, maybe not. I'm just going to show it to you, and then I'm going to kind of explain where it all comes from. So our area formula for a trapezoid is 1/2 base 1 plus base 2 times height. All right, so where does that come from? So first, let's draw a trapezoid. Now, there's a couple different kinds of trapezoids you could draw. You just need to draw something or be looking at something that has only one set of parallel sides. So we could also be looking at an isosceles trapezoid. That's okay. These will look differently at first, but it'll all come together and I'll show you it's the same. Okay, so if we were to break this into shapes that we already know how to find the area of, then on this first one, if I break it right here, then I have a rectangle. Maybe it's a square, kind of looks like a square, but a rectangle and a triangle. So if I wanted to find the area of those two, couldn't I do the area of the rectangle plus the area of the triangle. Awesome. Okay, now same thing over here. If I broke this here and I broke this here, then we could find the area of this triangle, and then we could add the area of the rectangle, right? Now, there's one other thing to consider though, besides just doing that. If we were to take this shape, and instead of breaking it into a square and a triangle, what if we just broke it into a triangle and a triangle, right? So the area of our trapezoid is the area, we'll call it triangle 1 and triangle 2. All right, so I'm actually going to use this, since we just talked about triangles, to prove to you that this is the area formula for a trapezoid. Okay, so if I call this triangle 1 and this guy triangle 2, then to find the area of triangle 1, we would have to do base times height. Well, what I have right here, this is actually a right trapezoid. Those are perpendicular. We have a right angle. So this would be base 1, right? And this would be base 2. And then that means this is representing the height of this triangle because it is perpendicular to this base, right? So the area of triangle 1 would be 1/2 base 1 times height. Now, why did I call it base 1 and not just base? Well, the reason I'm calling it that because I have two triangles with two different bases, and you can see that this base is not the same size as that base, so I don't want to call them both B. We can't have the same variable standing for two different things. So I'm just going to call this one base 1, this one base 2. It doesn't matter which one's 1, which one's 2. I just chose that one because it was the top. So this is the area of triangle 1. So then how do we find the area of triangle 2? Well, triangle 2 is right here. It would be 1/2 base times height, so 1/2 base 2 times height. Now, where is the height, though, in triangle 2? Well, most likely, we would probably draw it from that vertex all the way straight down. Do you notice that this height right here is the same as that height right there? Which means when I do 1/2 base 2 times height, these h's can be the same h because they are representing the same distance. All right, so how does that help us turn into this? Well, here's where our algebra skills come into play. Now, I am not going to ask you to do this or prove this. I just want to show you where this comes from. So do you see between these two bits, this has a 1/2 and an h, and this has a 1/2 and an h? Since both pieces have it, it's called the greatest common factor. Does that verbiage sound familiar? So your greatest common factor is the biggest set of numbers or variables that two things have in common. So if 1/2 and h is my greatest common factor, then I can factor those out, and then I would write down what I have left. So factoring it out means to get rid of them, to divide them. So if I take out the 1/2 and the h, you can see I have a base 1 left. And if I take out the 1/2 and the h, you can see I have a base 2 left. And do you see now that this formula and that formula are practically identical, just the h is in a different spot? Well, that's the commutative property again. It doesn't matter what order you multiply. So we actually get the same thing. So how can you use the triangle formula to help you find the area of a trapezoid? A trapezoid is the sum, we're adding them together, of two triangles. So if we found the area of each triangle, we can add them together. So that means the area formula for a trapezoid is going to be 1/2. Now, if you don't like the 1/2, you can divide everything by 2. And where you put the h in the front or in the back is totally up to you. It's just kind of how you've learned it. I'm going to write base 1 plus base 2 times height. If you don't like the 1/2, you can use divided by 2, or you can use 0.5. So it would look like that. Okay, so let's look at example 3. Let's put it to use. Find the area of the trapezoid with bases 14 and 20. So my shorter one will be 14, longer one is 20, and my height is 8. All right, pause the video, see if you can get it right. All right, so area formula, 1/2 base 1 plus base 2 times height. So we're looking for the area, plug in what we know, 14 plus 20 times 8. Now we just have to do the math. You can put all of this in your calculator. You can multiply in whatever order you want. I'm not going to use my calculator this time. I'm just going to kind of add things together. So 1/2 14 plus 20, so that'll be 34. Now I'm going to use the commutative property. I'm going to do half of 8, so that's 4. So 34 times 4. Now to multiply these together without a calculator, I'm going to think of it as 4 times 30 and then 4 times 4, and then I'm going to just add those bits in my head. So 4 times 30 is 120. So this is 4 times 30 plus 4, right? Because that would be 34. And then 4 times 4 is 16. So my area is 136 meters squared. Now let's just double check that with our calculator. Sometimes our math is off a little bit. So I've got 1/2, so I'm going to use 0.5 times 14 plus 20 times 8. 136. Again, meters are squared because we're finding area. We're literally talking about how many squares would fit inside our shape, right? All right, last one. I'm trying to talk fast to get through this. Find the missing base of a trapezoid. So it doesn't tell us what kind of trapezoid it is, so we can draw a right trapezoid, an isosceles trapezoid, it doesn't matter. I'm very visual, so I love to draw pictures. It just gives my brain something to kind of look at and helps me understand the problem. So my height is 10. So that's my height. It's going to be perpendicular to both of the bases. Base 2 is 18. Doesn't matter which one you call base 2. We're going to look for base 1, and we know the entire area is 200. All right, so we've got this formula, 1/2 base 1 plus base 2 times height. Let's start plugging in what we know. 200, 1/2, base 1, we don't know. We do know base 2, and we know the height is 10. Now, from here, there's multiple ways that you can start to solve this. Totally up to you. You can get rid of the 1/2 by multiplying both sides by 2. You can get rid of the 10 by dividing both sides by 10. I'm going to use the commutative property here. I'm going to do 1/2 of 10, which is 5. Now, even now, I have multiple strategies. I can divide both sides by 5. I can distribute the 5. Doesn't matter. It's up to you what you want to do. My preference is to divide by 5, just because it's fewer steps. That's the only reason. So 200 divided by 5, 40. B1 plus 18. And we're going to subtract 18 from both sides. And we get 22. Now you can see from my picture, my base 2 actually was the shorter of the two bases. So this one should have been the 18, right? And then that would make this 22. Since we didn't know what the picture looked like, we had to make an educated guess. And so that's just what happened. Base 2 will not always be your long one. Base 1 will not always be your short one. All right, if you have any questions about these notes or as you start to tackle the homework, please reach out and let me know. I have Zoom office hours. You can also email me throughout the day. Otherwise, have a fantastic day.